Good afternoon, everybody. My name is Vijay Gurbaksani. I am the director of the Center for Digital Transformation and looking forward to the session that we've planned for you with Dr. Sharon Zhou, CEO of Lamini. But before that, just a few words about what our plans are for this afternoon. So again, good afternoon to everybody in California. Good evening to those of you on the East Coast, Europe, and Asia. We're delighted you could all join us here for the first event that we're hosting in 2025. For those of you who aren't familiar with what the Digital IQ series is, it is our attempt to demystify emerging technologies, and particularly AI and increasingly generative AI, but really with the aim of helping all of you, helping make it easier for all of you to embrace AI solutions, in particular generative AI. And we're all familiar now with large language models. We're familiar with the limitations of large language models, like hallucinations and the kinds of errors they make. And of course, with the breaking news of DeepSeek and what they pulled off in terms of algorithmic advancements, which happened, of course, after we planned this event, we thought it would be very useful to have an expert come talk to our community about how what the landscape is for generative AI, for large language models in particular, what their shortcomings are, and how sort of some companies are actually improving what is available to all of us to use, and really sort of make it easier for enterprises to adopt generative AI. So with that, let me welcome Sharon, Dr. Sharon Zhou. She is the CEO of Lamini, and she has sort of an incredible track record of achievements first. She's the first Harvard graduate to major in computer science and classics. I think I found that particularly interesting, and we'll talk about that later. But she got a PhD at Stanford, where she trained under Dr. Andrew Ng, who many of you probably heard of as one of the pioneers in AI, and then was a faculty member at Stanford, worked in a variety of sort of AI-related positions. She's one of 300 people in the world who actually know how to, you've probably heard this number, build large language models. And so really is sort of one of the true experts in sort of the whole area of generative AI and large language models. So with that, let me welcome Sharon and turn the floor over to him. Sharon, if you could turn your camera and your mic on, that would be fantastic. And perfect. Let's welcome Sharon. And Sharon, please take it away.
Awesome. Thank you so much, Vijay. Cool. So let's see. Let me just share my screen here. So I'm Sharon, as Vijay introduced. I'm the CEO of Lamini. Before this, I was faculty in computer science at Stanford, leading a research group in generative AI with about 50 students. I did my PhD there, as Vijay mentioned, with Andrew Ng. It was in generative AI as well, and specifically in evals, if you've heard of that. And then I also teach actually a few million people online in the space. I know far fewer than Andrew, but I had the opportunity of teaching a lot of great folks out there on Coursera in generative AI and fine-tuning LLMs, for example. We recently launched a course with Meta on how to improve their models. It would be exciting to kind of see how this works with DeepSeek as well. And before my career in generative models, I was a product manager at Google, where I worked with Fei Li as in her group, working on discriminated models. So being able to do vision classifiers and detection. Cool. So that's me. I'll talk to you today a bit about kind of what we've learned at Lamini. I've talked to hundreds, maybe thousands now of enterprises about what the biggest pain points are in terms of how they're developing these models and using them internally for high ROI use cases, and kind of where we have focused on as a result. So Lamini is a developer platform to make AI not hallucinate. And we do this by changing how LLMs can think, by adding new capabilities to them, similar to how what OpenAI does internally, right? They add reasoning capabilities. DeepSeek added reasoning capabilities, but we do a different type of capability that's not necessarily reasoning. It's along a different orthogonal axis, and it's around hallucinations and removing them systematically for for developers, for enterprises to do that. And we found that this is one of the biggest gaps in these models for them to be useful in the enterprise specifically. So we're backed by really great investors and wonderful folks like Andrew himself. Yeah, so our platform really just enables people to get to that very high level of accuracy on their use cases by removing that hallucination piece. And if you think about it, in terms of people, I think the reason why hallucinations are so detrimental is because it almost feels like the model has short-term memory loss. And so it's removing that from the model. And then if you can really remove hallucinations, not just in the short term in a conversation when it makes something up, but at scale, then it is better than a person, right? A person can't remember all of those facts all at once. So it's a very powerful technique. And one, I think that is a type of capability, type of intelligence, so to speak, that is important for these models to learn. Okay, so stepping back a bit, talked to a bunch of enterprises over the past couple of years. I actually started the company before ChatGPT launched, just a couple months before. Since I promise you the technology was exciting then as well to us researchers, but I know the world kind of found out about it when ChatGPT launched. This is kind of the maturity curve I'm seeing across enterprises building with this technology. 2023 was very much marked by exploring, right? Working with off-the-shelf solutions, building chatbots, starting to just play. And I would say moving into 2024, I saw a lot more experimenting. So being able to build in-house tools for very obvious use cases, hooking it up to my database in some way or hooking it up to my documents in some way. And people were starting to use RAG, retrieval-augmented generation. Data pipelines were still fairly immature at that point. And then this year, I'm starting to see people starting to move towards this implementing stage, which of course, the more mature folks are already there, but essentially having much more mature data pipelines, getting the data in the right format, being able to actually move from, RAG solutions, more complex RAG solutions to starting to fine tune, starting to edit the weights of the model, and exploring higher value use cases. And then finally, we see some folks at the scaling stage of maturity where they have much more mature evaluation pipelines or evals so that they can actually measure their progress very systematically and not just go by what people call vibes of the models and not just go by their intuition or feelings of how the model goes, but actually are measuring it and understanding exactly what ROI they're getting from it and being able to then incorporate those learnings into the model itself and teaching the model new capabilities. And that's where we're seeing a lot of production use cases there. And so here, I think some use cases in prod and here many more. Okay, that's helpful. We're also seeing kind of a different landscape of, how people are tackling different use cases at different levels of value. So probably at the lowest level is, hey, let me just hook this up. It's okay if it makes stuff up. It's okay if it kind of makes up how to reset your password, because if it's wrong, it's not going to hurt the user. They can find that information in a different way. But there are some things where it can't get that wrong, right? So you don't want a payment to be wrong, like the exact number that you're supposed to be paying, for example. So some things can't be wrong. So as we move up in requirements for accuracy and removing hallucinations, we also see kind of an emergence of new use cases from that. And something that I find really interesting is a bit of this observation of this inversion in the labor markets between the human labor market and what I would say is the AI labor market. And I say among people like general purpose humans, like to be an Uber driver, is not that it's not that expensive, an Uber driver, but a rocket scientist is, and that is an expert, right? That's among humans. For AI, it actually might be inverted. So the general purpose monolith might be actually quite expensive to build because it's so big. It needs to know so many different things. He needs to drive, it needs to cook, etc. But the expert that can only be a rocket scientist is actually way cheaper. You can get away with a much smaller model that is very highly specialized to that task and doesn't need to cook or drive. So I find that inversion really interesting and is an opportunity for arbitrage. Cool. So I think a lot about like hallucinations because I think that can get you to that level of accuracy that you need very systematically. And I think the most dramatic levels of accuracy that I've seen are like 3 nines of accuracy. Being able to actually talk about nines is, I almost feel like a luxury in the AI space, but essentially being able to systematically remove each hallucination and actually get to a place where you can manage that level of risk. So over nines of accuracy. There are a lot of different techniques. I'm sure you're familiar with a bunch of these. So first you can just talk to the model differently, right? Like, hey, don't do this, do that, and let the model figure it out in the prompt. That's the easiest one. Everyone can edit their text message to ChatGPT, for example. The next step is retrieval-augmented generation, which is searching through all of your data and picking out the pieces that you should put into the prompt so that you can steer the model in the right direction with the right type of information. Next is fine tuning. So this is a technique that ChatGPT used to basically change the behavior of the model and actually add a little bit of new knowledge to the model as well. And then we've developed different ways of RAG and fine tuning, kind of inspired by the basic approaches out there that focus heavily on hallucination reduction. So being able to create embeddings, basically do RAG in a way that really focuses on the facts so that the model doesn't hallucinate on them and the model doesn't need to really think about, oh no, did I remember this fact correctly or not? And then memory tuning, which is actually putting the facts inside of the brain of the model itself and really making sure it remembers them and doesn't hallucinate on them. And these approaches, are different along these axes of ease of use versus high accuracy. And we're really focused on like something that I care about is making sure that these techniques are easy to use because otherwise people are not going to adopt them and they won't be able to build effective models from them. And you'll need teams of people like me, hundreds or thousands of them, to accomplish that. And I don't think that should be the case. So something, yeah, I think about a lot is how do we actually ensure people can get value from their data. And I realize it's not just the algorithms, right? It's not just, oh, hey, we have this memory RAG thing that helps you focus on the facts. So, hey, we have memory tuning. Like at the end of the day, it's very dependent on your data. And so something that I've also been thinking a lot about is how do we make this data piece, how do we make sure we make the most of your data when we add it to the model? Because the model's only as good as your data. And I think the realization is that when it comes to building a general purpose model, you're often dealing with, hey, I want to do all of these different tasks. But then when it comes to remembering facts about your data, it actually doesn't generalize or it doesn't translate to another company. For example, if I'm trying to build a model for that doesn't hallucinate on JPMC's, JP Morgan Chase's, schemas, internal SQL schemas or something like that, and it writes perfect SQL to their schema, it's going to look very different from that of Amex's, the schemas at American Express, right? And they might even contradict each other. In fact, they will contradict each other when you ask them how to calculate like TAM for something or some kind of other analysis. And so as a result, you almost want different facts for each one, and you can't have one model that does both of those things necessarily. They will contradict, those facts will contradict, and you want it to be 100% sure when you're asking it. So something I've realized is we need to expose a way for people to easily adapt their data and their facts and their know-how and distill that into these models. And that is incredibly important. And so that's what these data agents are for. It's being able to put in your specific facts and to adapt the pipeline to do that. Yeah, and this whole piece is something that I know that the foundation model companies spend a lot of time on is the data piece, as well as the algorithm piece, but definitely the data piece to get that into the right shape. Just as a small little anecdote, Meta, they have a ton of data, right, to train the llama models, but they actually only use 1% of it. And if you ask them if they had more compute, would they use 2% of it, right? If they double the compute, and they say, no, I wouldn't. I would actually just continue using my 1% of data because it's so valuable and in the right format. And so that's exactly what this is getting at. You want it to be in the right format to be able to get the best outcome from the models. And that's what people are talking about with DeepSeek. Like they really, because we have these giant capable models now, we can now get away with smaller and smaller models because these big models can help us get to that higher quality data. And a lot of that process is, you've heard the word distillation, distilling the model to that smaller one. This is a very similar process, taking your data and trying to find the most valuable set, a way to represent that data in the best, highest quality way, and then feeding it into the model. Okay, I also get asked a lot, so those are techniques to remove hallucinations, but I also just get asked a lot, like, why do these models even hallucinate? There are papers out there saying they're designed to hallucinate, and in some ways they are. The pre-training phase, not fine-tuning, but like pre-training, they are. And I'll tell you why. And there's a technical reason why. And it's because they've been trained to crawl like this internet of data, and they're trained to predict essentially the next word. And so if it predicts something similar to what's right, it basically is able to develop all these similarities and is trying to reduce what's known as generalization error or average error across all examples. So as a result, it's pretty good at everything, but it's perfect at nothing. Okay, so it turns out for facts, you actually have to be perfect at some things. You have to remember like a date, for example, and that's very hard for this model to do in the way that it's been traditionally trained. And so as a result, it's going to just make up a date or find a similar date. And that'll I think that's approximately correct. Now, let me just step back with another example. Sometimes for non-facts, you don't care about this actually. So if I said hi versus hello, those are similar enough. It doesn't really matter which one I say. It's actually a good thing that it's able to know that those are the same idea, because if it didn't, then if it could only answer hi but not hello, that would be a problem. It would just not be useful. It'd be a lookup table. So it's a very powerful technology. It's able to do that. However, if it applies the same mentality to May 1981 and May 1970, that's a problem. And so yeah, that's a very big problem. So that's why it kind of hallucinates and makes up facts, because it thinks they're approximately the same, and it thinks it's a believable next thing to say. So something we're focused on is, well, how do we still keep the magical nature of hi versus hello, right? That's important for the model to know this knowledge. That's why we actually find these models so magical in a way, because they can flexibly handle human communication and speech. But then how do we also embed these facts, or these words, these tokens, these facts, these concepts into the model so it doesn't do that to those things. And that's what I'm really focused on and have been concerned about, and realize it's actually not a philosophical problem. It actually is a technical problem. And with a technical problem, you can apply a technical solution to remembering those facts. So yeah, I think about this a lot, and these are techniques that are we've been building out at our company, which is, okay, well, let's keep that magical piece and then let it remember specific facts. And then of course our customers put in those specific facts that the model needs to remember. I'm actually just going to jump into use cases. This is just kind of defining why memory is necessary. I kind of said it. I mean, I think it needs to remember some of these facts, be able to use internal systems, external ones more appropriately. You've probably heard about agents. I think it really is important that these essentially agents or agentic workflows that hit internal databases, for example, or executes actions on behalf of a person are able to have reliable memory. Maybe just diving into some use cases, because I think people find that potentially interesting, of like, what are other companies building out there? So one is a large biotech company that we work with. I really like this use case because it not only helps them make money, but it's also good for the world. Essentially, they're taking a process that takes them 3 to 5 years today to help with oncology research. and propose like drug combinations down to weeks or months. So that's super exciting. Like, how do we actually take this very historically long process of sifting through research paper after research paper, and then also like PII data internally, right? Like trial data, and put that all together and understand like what possible drug combinations could cure this cancer or help with this cancer. This is very exciting. If you step back, this would be probably extremely transformative to this industry and to our lives, right? If we could bring it down from years to months or weeks. So I'm very excited about this. They were able to get very high accuracy, which is why they needed it, because otherwise it wouldn't help them necessarily predict things and bring down the timelines, and the savings were big as well, of course. And they needed to combine, they really cared about data privacy as well. So they worked with these open models and were able to tune them to high accuracy, since they have PII data that they didn't want to send outside of them. Another interesting use case is a household CPG company. And they wanted, they have a huge kind of procurement supply chain org. They had a lot of business teams as part of that, as well as like factory workers. And if something went down at some point, so let's say production was halted because something was wrong with a part, someone in South America would have to call someone in Germany who spoke both Spanish and German to read the German manual, and talk to the database there in German to figure out why that part went wrong, and then translate that back to the person in South America. So I thought that was just such an interesting use case of, obviously that's probably the most extreme phone call, but that they could, see, oh, that clearly halt all of production, which is waterfall. And this can quantify the halt to production. But then also, can we automate that process, right? Can that person get that answer immediately instead of having to go through all these steps? And so right now, the big bottleneck for a lot of what they are trying to answer, there's so many different questions that are being asked from their internal 30,000 team members. It's bottlenecked at the data science layer. So they really needed this model to work to help service their internal users. And accuracy was, of course, very important. And they initially had only 30% accuracy using GPT-4 with RAG, and they really needed it to be something closer to 90% to even deploy it. Otherwise, it would just be making up. It was basically making up schema information, etc. And their schemas are very complex. So I think the general purpose models can handle simple schemas, etc. But within this company, very, very complex kind of knowledge being added to it. Maybe this column was useful for these months, next column is useful for those months, these two columns are useful for the last 3 months, something like that. It's just, there's a lot of complicated history inside of these schemas that need to be added into these models to accurately query them. Cool. I think we have customers kind of working on other use cases, like just generally processing text, classifying that text into a high priority, low priority, or a lot of different classes, like thousands of different classes. And of course, function calling as part of the agentic workflow, being able to call functions and use tools and perform tasks. Another one, financial services, of course, customer service agents need to be able to respond accurately. This is just another one here. Yeah, so just spanning a lot of different use cases. We see that, accuracy can actually get you to a different type of use case, which is really exciting because I think, I think everyone has touched these models at this point and realized they can do a lot of cool things, but feel like, oh, there's still some limitations to them, and we'll just wait for some of the capabilities to show up. But I think actually a lot of the capabilities are in our hands now, and a lot of them won't show up from better generalization or reasoning. They have to show up through removing hallucinations, which is a different access from a technical standpoint. And so I'm really excited to see more use cases, especially higher value use cases, emerge that are tailored to different businesses. Cool. So people often ask me how a lot of this works. I think we have a couple slides here. Maybe, I don't know, Vijay, do you think I should keep going?
Um,
What does the audience
yeah,
say?
just take a couple of minutes to wrap. I'm going to come back to some of these, and I'm going to ask you questions about those.
Perfect. Perfect. Okay, cool. So people ask us, I'm happy to, walk through some of the intuition behind our technology. But basically it follows two different trends in AI. One is LoRa's. So LoRa's make it possible to basically not tune the entire model because that's very expensive and also unstable, but only tune a few extra, I would say, brain cells on top of the model to adapt it to a different task. The next technology that we build on is called mixture of experts. You probably saw DeepSeek was built on this. GPT-4 is rumored to build on this, but essentially it's instead of, when you ask a question, like how are you, it goes to the whole model, and you ask a doctor's diagnosis. It also uses the entire model's brain to answer the question. But we don't use our entire brain for all the tasks that we do. So why don't we split up the brain a little bit and specialize them to different things? So one expert might be good at answering doctor's diagnoses. Another one might be for just general question and answer. So it just specializes it so that each time you ask a question, it only uses a fraction of its brain. And essentially what we do is we combine these technologies. So we keep the base frozen of the model, and then in the LoRa's, so in like the extra little brain cells that we tune, be able to have them be a mixture of experts in that layer. So there's just only choosing a few of those extra brain cells every single time we work with it and ask it a question. I'm happy to dive more into that. This is what it looks more technically, but essentially this is how we were able to get the model to remember these facts. It's in those extra little brain cells that are specifically adapted to people's facts. And ultimately, the value is really just getting nines of accuracy and being able to get away with a smaller brain that can achieve more, a smaller model that can achieve more. And just finally wrapping up, I know I mentioned the course, but definitely recommend it. It's a way to walk through it in code, but also hear it at a high level of what's going on. Cool. That's it. Thank you.
That was fantastic, Sharon. I think I've turned my video on. If you could turn off your sharing of your slide, that's perfect.
Cool.
And Nina, if you could, maybe this is the view that I have to change. Here we go. Perfect. I'm now in gallery view, so I can see myself and see you. Now I see why you have 1 million+ students on course.
No.
You are such a good teacher. It's fantastic to see, and I learned so much. Now I'm going to have to take one of your courses.
Please do.
I got my degree in CS many years before you, so this stuff was not taught. But so this is fantastic. The thing that's really appealing to me about what you said is because largely, in economics, we talk a lot about general purpose technologies, and sure you're familiar with all that the terminology. And large language models are basically a general purpose technology. And sort of one of the requirements for these is that you have to have sort of make these technologies your own. So you have to customize them and invest fairly significantly in sort of capturing the benefits of the innovation. And what you've actually done, which I think is really innovative and important, is made it so much easier for businesses to actually embrace the technology. And that's sort of what's required in this overall evolution to success, not just in terms of profitability, but like, the cancer example was fantastic, right? Because we want to make it easy for pharma companies to develop new drugs far more quickly than they've been able to do in the past. So that was, I think it really sort of, for me, showcased the pathway to value, which I think is really important. But let's start with some fun stuff about you. So you went from academia to being the CEO of Lamini, but I want to start with, you majored in CS and classics. When I was studying CS in India, the classics was not an option in the Institute of Technology, though I think if there was classics, I would probably not studied CS, and only if my parents had allowed me to not do the engineering and just do something that will get me a job. So I'm curious about sort of how you picked that and how you think it's changed your perspective on leadership in this highly technological world we live in.
Yeah, so I think in some ways I'm very different. I started off in classics. I did not start off in CS. In fact, I took my first computer science course because I was so bad at using technology. Like I was just made fun of for using technology. It broke so many phones that I figured I had nothing to lose. So I took that class and I realized after that class and after the next one, a user experience, that it's, quote, never the user's fault. And it made me realize, oh, wait, if it's never been my fault, first of all. Second of all, this means that if I were to become a technologist, I could see the problems that could, that intimidate users, that intimidate me, and I could design technology to make it more approachable and usable. And so that's what really attracted me to technology, is from that angle. And it's almost like the human piece of how do we serve people with this technology, and how do we make them not feel intimidated, but make them feel like they want to use this technology and blend with it and it helps them. So part of my personal mission is just to combine like the magic of what I see in technology with human warmth and human stories. And I do that a lot through my courses. It's the reason why I started off as a product manager. I didn't think I would do a PhD. The goal was not to graduate, by the way. But I loved kind of product and building out products. And I did that first. And then so I've always been kind of led by the human aspect of things. And I think that hopefully shows up at the company, both internally and externally in our product. But essentially, the goal is to make it possible for you to not necessarily need all of OpenAI's team to achieve, in some ways, what OpenAI has achieved, to steer these models, to really be able to control them, to build your own types of intelligence into them, and not just go off of someone else's definition of intelligence. Because I think if you take it to the extreme case, and I think these enterprises have seen it, is that if you outsource all of your intelligence to a few other companies in the world, then you become a shell distribution channel
Yes.
to them, right? Like you don't have intelligent work at your company anymore. And so how do you make that not the case, because that's definitely not a good future path for yourself. And I think this is how it's saying, okay, well, let's invert the model, the business model. And let's make it so that our customers, the enterprise can actually own the model themselves, and we'll just sell the tooling to get them there, and make it easier so that they don't need necessarily people like me to do it. And so that's something that really matters to me. And there's still extremely intelligent, in some ways, way more capable than me people, developers at these companies building these things, but they don't need that level of AI expertise to put that knowledge into the model.
Yeah, before I ask my next question, I do
Yeah.
need to make an announcement that I forgot, which is,
Okay.
as Dina's already indicated, we don't take questions on chat. So if you have a question for Sharon, please post it in the Q&A function in the webinar. And I'm probably going to go to your questions in about 7 or 8 minutes, I'm guessing. But going back to what you were just talking about, Sharon, because I think it's
Yeah.
really important to highlight. One of the things I always talk about in my classes and the talks that I give to industry is ultimately you have to focus on, as a company, on what makes you different. And
Yeah.
what that is exactly what you were saying, which is distinctive know-how, your distinctive IP. So one of the questions I ask companies always, like, if you could imagine a patent wall, what would you imagine putting on your patent wall? Whether you actually do it or not is a separate question, but it's a way of sort of forcing them to think about what's unique about them and what is worthy of intellectual property protection. And you get some very different answers from the instinctive stuff that people actually give you. And I think what you are doing, which I think is just so extraordinarily valuable, is allowing them to capture and leverage their distinctive know-how by building sort of your layer of model on top of sort of the general purpose technology. Would that be a fair sort of characterization of?
Yeah, that's exactly it. Yeah. Give everyone the steering wheel. And right now, the car that you need to drive to be able to do it is, okay, sorry, I don't know cars well, but like F1 racing car, like something really hard to drive. But you know what? I think we can build a Prius and then everyone can drive it. okay, fine, people might not like Priuses. I love Priuses. You know what I mean?
Yeah, but you're right, because Formula One cars are extraordinarily difficult to drive. I did a simulator one time, and you get a workout. It's
Yeah.
those are really, really hard to drive. I think that point is extremely well taken. So, what is the pro what is the when you walk into these companies, what's your sense of where they're at? Like, where are they stuck? And then what do you leave them with? You build a sort of a model, a product for them that they then run on their own?
Good question. So they're usually stuck on, hey, we've identified these use cases. We two things. One, we don't have enough people to be able to build them out and get to the right level of accuracy we can deploy them to. Like these are in demo mode. We can't deploy them because the model is making stuff up. And we don't have enough either time or people or expertise to be able to achieve that. And what we leave them with is the time returned and enabling their team to actually have the expertise to do that. And so ultimately, our POCs are run very quickly on the order of weeks and or days, I guess, if you're a startup, but weeks for an enterprise. And basically they see performance improve on the model very significantly, like that 30% to 90% immediately on their evaluation set. And they're like, okay, wow, I saw this in way less time than I've been spending. I spent this many people for years, months, whatever it may be, but I saw this in weeks, days, that I could get to this accuracy. That's the first thing, like seeing that value really quickly. And then the second aha moment is, oh, I can do this on my own, because we have the tooling to make it possible for you to do it on your own. So yes, you can continue improving it. You can scale it up to more data, more use cases on your own. And so that's what they're buying. They're buying that essentially platform to do it. And so then they can go off and do new use cases. And we've started to see customers do that, where there are use cases that we don't even need to know about, right? Like we don't even need to have visibility into. And that's the beauty of it. Because otherwise, if we were like a consulting firm that helped them implement each of those, I mean, there's like IP and all the stuff that we would see from them. It's like for some of them, they're putting in their most valuable data, right?
Yeah.
So we shouldn't need to see that. They should be the ones covering that and being able to have the tooling to do that. They're driving the Prius, not us with their supervision. Like they're driving it. We don't have to be in the car. Yeah.
No, so the thing that I think is really powerful about what you're talking about here is, you know, you're sort of, I don't want to use the word underplaying, but there's a tremendous amount of expertise that you're bringing to the table. So it's not surprising to me that most companies sort of don't possess the kind of talent bench that you have at Lamini, for example. So there's a huge amount of expertise, not in sort of understanding how large language models actually work, building the layer above all of them. And then of course you get economies of scale because you're not just doing this for one company. You're talking about memory tuning, fine tuning, whatever, across a variety of companies. So it does make a lot of sense that expert firms like yours are actually playing a really crucial role in this whole ecosystem. Um, uh, which gets into this whole degree of competition and among big tech, because with DeepSeek, one of the conversations that is it's all over my LinkedIn feed these days, and actually it's on TV now, I'm told.
Yeah.
When it makes to the big TV news shows, you
Yeah. I don't know what TV is, but okay.
Yeah, I've never watched live TV any myself, but it's sort of so. What do you see? Like, it's not exactly a question about what you do, but what do you see as the future of that whole layer of these large, these big tech providers of the big foundation models? Because like, how much room is there at the end of the day for like as many players that there are? And then how do you sort of place the bet on which ones do you work with? Or I'm guessing you have a pretty open sort of way of accessing pretty much any foundation model, but let me hear it from you.
Yes. So I think the first thing is this was not obvious to the world a few years ago, right? And
I'm sorry,
the
what was not obvious?
open models
Yeah.
would meet or surpass closed ones. And I think we actually started the company on the premise that that would happen. We build on top of the open models, right? All our customers use the open models to then memory tune them. We also do
Uh-huh.
have a memory RAG you can run on any of the models, like closed models too, but memory tuning, you need access to the weights and architecture of the model to make those modifications. And so as a result, the closed models are not an option. But because you're putting in so much of your data, it might not matter because at some point it will surpass the closed model on your specific specialized use case. And so that was our bet. And when we started the company in 2022, I will say the best model was something called Pythia. I don't think a lot of people have heard of that, but I will say when you ask it, what is your name? It will answer sometimes. My name is, and just like it's stuck on the word is. And that was the state of the art back then. Okay, that was incredible. That was like, oh, wow, so good. And then of course, the Llama models made a big breakthrough of showing, oh, it might be getting close to where some of the foundation model, OpenAI, models, foundation models, closed ones are. But then people still said, oh, but there might be still a lagging gap. And then now with DeepSeek, it's like, maybe it's actually just going to be better. I think like that progression year by year has been extremely interesting to watch. And of course, it helps us a lot because then our customers all are, can run on DeepSeek, for example, and be very happy with that. And it's fully private, right? So it's like their whole thing, like they own the whole thing. And so they don't have to share it with anyone necessarily. It's proprietary. And so it's been fascinating to watch that progression. And I would say that a few points have been surprising to me, a few haven't. So I think I expected this progression. I did not expect it at this. I think this was faster than I expected, but I had a sense that this could happen. And I can say why. And then I think the other thing that surprised me was that coming out of China did surprise me. I thought like
It did
it
not
would be a
surprise you.
group here. No, it did surprise
It
me.
did surprise me.
Yeah, especially with given the export controls, et cetera. But I think the thing that didn't surprise me is that open source would get better because I think it was already hinted at because OpenAI was starting to make smaller and smaller models to run them faster and cheaper, and they were still some like pretty capable. And you can see with the large models, they can create better, like good smaller models by essentially compressing them, right? Because
Right.
and you have to start with the bigger model though, because you like it's easier to just put data in, but not all the data you put in was high quality. But now you can use this big model to create high quality data and it's more compressed, and then you can compress it further into a smaller model. So
And
that
that's
progression makes a lot of sense.
that seems to be the allegation that OpenAI has, that you're using sort of using distillation on our model.
Yes. Mhm.
Right? Is
Mhm,
that
mhm.
correct?
Yeah, that is the argument. It's really hard to say though, because then the internet also has a bunch of like data that are OpenAI outputs that are just out there. So does that count? Yeah, so it's just
And the
yeah,
and the IP laws are so unclear on a lot of these issues.
yeah, and also isn't it allowed to do that for research or something? So
Yeah,
it because it is MIT license and
yeah, I get it, yeah.
yeah, it's hard to say. Yeah.
So I'm going to ask Sharon one more question, then I'm going to just turn it back to turn it over to the audience. We've got a lot of questions already. But
Yeah.
from an algorithmic perspective, what do you think DeepSeek's achievements are? The
Mm.
big ones.
I mean, I think the biggest thing to take away from it is how important synthetic data is. And I think some of us in the community already know about this, but for the most mature use cases, so I'll just talk about machine translation. That's the most mature use case with LLMs. It was the original Transformers paper was about translation. And it's reached a level of maturity that is actually astounding. And I'll just tell you why that is. So at Google, of course, they have the best translate there. Uh, their team has shown that synthetic data is better than human data
Yeah,
as rated by humans. So that means we don't need human labels anymore to
yeah,
improve this.
that's very
Yeah,
powerful.
so just sit on that and realize, oh, like we don't need us to make this thing that's better for us. So sitting on that, that's really interesting. I mean, we needed us initially, right, to start essentially tuning the preference model. But once we have the preference model, it is better than us creating data, because we can make the preference model the best of us, for example. So I think that's really interesting. And I mean, they definitely leverage that technique and leverage that heavily in their work. And it's something I think about a lot because we are relying on that a lot. We're basically telling our customers, like, you don't need to label data, you don't need to go to scale AI, like you can just get away with using these models and writing these data pipelines, agentic data pipelines, to be able to create that for you. And that's so powerful. And I think this just like shows an example of that. And there's more and more examples of that now. Because I remember, I don't know if you remember, Vijay, when people were like, oh, there might not be enough data in
Yep,
the
I remember.
world, right, to represent all this stuff. I'm like, no, that we're past that.
And
There
also
is.
you said Meta uses 1% of the data that they have. So, how much more do we need? But let me ask you a question because
Yeah.
the really interesting actually it turns out to be a follow-up to it's from Kiran Madi. He says, post-memory tuning, what tools your customers use to check that their models are not hallucinating in production?
Oh, yes. So I would say there is a lot of like observability tooling out there. A lot of our customers also roll out their own for that. So just like monitoring software of what inputs and outputs are putting through. And then we also do have evaluation pipelines that are built out that use I would say not just one LLM as judge, but like many LLMs as judge to assess whether as an output is high quality. So it's just a constant assessment of that and constant orchestration of that pipeline. Um, Evaluation is incredibly important. I don't know if I touched a lot on it here, but I see a lot of half-baked attempts at it. But it is incredibly important because essentially, I think we've basically solved optimization, which is like we've been able to figure out how to optimize towards an objective. But what evaluation is defining the objective.
Yeah.
So if you define your objective poorly, how is the model supposed to get to the right place? It will get to exactly the place you tell it, and it will get there way better than a person. It's like so precisely getting there that if you define it wrong, it will get it exactly in the ways that you
I'll do the
specify.
wrong thing really well.
Yeah. It'll do exactly what you say, but if you say the wrong thing, it'll do exactly that. It's kind of like parenting, I heard.
In
So,
parenting, you get many chances.
no, models, you get way more chances because you can start over. Um,
But your point's really important because when you start thinking about a world which is sort of agent dominated, or dominated maybe too strong a word, but agent powered, you got to make sure that these agents are doing the right thing consistently. Like you can't have hallucinations in year two and suddenly say like, now we have these crazy sort of outcomes. So I think evaluation is, it's always, I've been in this business for a very long time. And we used to have a phrase called post-implementation audit, and companies never did it, which is once the system was launched, they sort of stopped worrying about it. And I think this is even more important in sort of in the age of AI. Um, One of the questions from Vas Bhandarkar is about, with this is sort of, I think, a broader strategic question. When you've got these large language models, reminds me of Amazon and sort of how we're copying retailers who had successful products on their site. But as smaller companies build smaller relative to sort of the big tech companies, showcase things that are valuable offerings to end customers, how do you manage the risk of ensuring that you have a moat and that your contribution is not overshadowed by some of these of the foundation models, because they learn, they can see what's happening just as well as you do, right? So
Yeah, definitely. So I think where we have a moat is building in a way that would have to really dramatically change, like they would have to dramatically change their technical direction and business to do what we're doing. And so those pieces are like hallucination reduction is orthogonal to generalization and reasoning. So it's a different axis. And as a result, pivoting to it is not a necessarily easy thing. You have to approach it very differently. It could hurt the other one a bit, right? And so that's one thing. I think the second thing is the way we approach hallucination from a business standpoint is making sure our customers can actually customize and specialize to their own definitions. And that means there isn't one right answer across the whole industry. There only is a right answer for them and exactly what they want to put into it. And as a result, they own the whole data derivative, the model, right? They own all of that. Having one of those other companies give the model fully to another customer, that's not their business model. That
Right.
is, yeah, I know, I mean, DeepSeek is directly threatening that business model right now, but like that is not the business model. And so that makes it challenging for them to pivot over. How many times have people asked OpenAI to open source their models? But it's fine. Like that's where they kind of are drawing the line for their mode, but we're drawing it as the opposite of that. And so what we need to do best though is make that tooling very usable and easy and improve time to that accuracy level for these smaller models so that our customers can get away with these smaller specialized models that are, you know, both cheaper and much lower latency and just they can use essentially many agents across their workplace like that.
There's a ton of questions about data, so I'm going to try and do my best.
Okay.
So, everything from sort of how do you ensure data quality
Mm.
to, how do you even know what the facts actually are? So we're starting with, which is sort of a version of the data quality question. Um, so why don't we spend a few minutes just having you sort of tell us about sort of how these companies, how you think about data quality and what you think what companies should do to sort of ensure data quality that's suitable for use in applications like yours.
So I think the most important thing to understand about AI that I think is really tough for people is with building more traditionally is iteration. What you want is not like, I want the perfect data quality right now, and I want to get to that. It's I want to get to the next iteration as fast as possible, develop feedback and analyze the errors and then improve it from there until I can iteratively get to the best data quality. So that's a very different mindset shift. I found that like machine learning engineers are actually a lot closer. It's a lot closer as a discipline to designers, like
Hmm.
product designers, than they are to software engineers. And that's been fascinating because it's like it's almost like design thinking, iterative prototyping. The iterative piece is very key. It's not the same, but it's very key. Um, and so what I mean by that is you actually don't know upfront what high quality data is. You have to react to the model. And the way you react to the model rigorously is to set up very reliable evaluation set of what you expect the model to be able to do. An evaluation set, it really is a exam for the model. So we've all gone through school. If I were to test you on a concept like addition, I could have 5 + 5 = 10 as on the test, right? But that doesn't cover all addition. I don't know, actually, I actually don't know. You could randomly guess 10 and I would think you know addition, but you don't.
Right.
Right. So I need to, in my exam, make sure you really do know addition as best I can, right? I mean, as thoroughly as I can. And you can be as thorough as possible, but it'll take more time to assess that concept. So essentially, that's what you need to be able to create. You need to be able to create really good exams. So maybe like teachers will actually be the AI people of the future, can create these really good exams for the model. And the exam has to be good and reliable. Otherwise, you are not reliably assessing their skills. Okay.
Question from
Yeah.
sorry, finish.
And then the rest of the data, actually, you can get away with more of what we call noise. So it doesn't have to be as high quality immediately. It just needs to be able to get the model to a place where it can do well on that exam. And the model can handle a little bit of imperfection. And then over time, you remove imperfection where it matters. And sometimes it doesn't matter in some places, and you just remove it where it matters to improve your accuracy on that exam. Because ultimately you care about its ability to handle those concepts, not like exactly what your perfect input data is. I don't know if that helps.
No,
It's a
it does
mindset
because you
shift.
actually turn
Yeah.
something on its head because everybody thinks about data quality going in, and you're actually almost arguing that data quality is sort of comes almost like later. You test the output of the system for data quality, which I think is sort of an interesting take, which is quite
Yes.
different from the way people traditionally think about data quality. I think that's important to remember. Here's a question from my colleague, which is somewhat on the technical side. While memory tuning can improve a model's ability to recall relevant context efficiently, it may introduce potential constraints on response time. Is latency a big issue for Lamini clients, and how do you tackle latency?
So it doesn't actually add, I didn't go into why LoRa's don't add latency, but it doesn't add latency because it fuses into the base model weights using low rank matrices, which is what LoRa stands for, but we can say using math to actually fuse it back into the model. So the extra brain cells that you basically adapt in the model can get fused in so that you're not actually you're running the same amount of brain cells at inference time. So it doesn't incur a latency cost or latency cost or a hit on cost also. So that's something that's extremely attractive in the LoRa paper. That's why it's the default way to essentially fine-tune these models. Now, and then the second question, latency. I think the way we address latency, so I mean, that's how LoRa's work, but essentially, I think there's a bigger thing with latency here, which I don't know if people really fully realize, is that if you think about it, if you have the tools to improve accuracy and along this hallucination dimension, and that's really what you care about, then you can get away with a much smaller model. And latency is caused by how big the model is. Like that is where your main latency is coming from. So if you can get away with a smaller model, you immediately can get away with a lot less latency. You're basically like reducing, that's where like latency is incurred the most, is this giant model that you're using. And if you're using a much smaller model that can have that capability, you can just get away with a lot less latency. Because there's at some point people have developed all these tricks, right? Caching all this stuff around the giant model to make it faster because it's so slow, but it's always just going to be limited by this giant thing. But then if you can essentially get away with the smaller thing to do something that's the same or even better, whatever it is, then you can still add all those bells and whistles around it, but you've reduced the thing that incurs the most latency.
So would it be fair to say, I was trying to understand this, that
Yeah.
when you talk about reducing or almost eliminating hallucinations, is that really about sort of in the context of this small domain-specific model? Because you can't reduce hallucination across, an entire.
Yeah.
So you're talking about in your business context, we can pretty much guarantee you'll get 4 or 5
Yep. Yep, exactly. It's not removing hallucinations from every domain. I mean, you could, it'd be extremely
expensive, and no single client will want to pay for that. I'm going to ask you one last question, and if people want, if I know we try to be exactly on time, but I'm just going to request you to stay a couple of minutes longer. There's a question about security, which I think we should touch on a little bit.
Yeah.
How do you ensure that GenAI LLM models are built securely? Tatiana Moore is a longtime alum from here and now works in security, so I know where this question is coming from. What are the main things that security professionals should consider when they test GenAI large language models?
What type of security are we talking about?
That we will have to ask her.
Okay. So one aspect of security that I think about a lot, because I know there's there's network security still involved with these models. There's such big, gigantic things. How do we deal with that? There's also security of I guess, guardrails on the model. There's also security of hey, I've tuned this model and now I have this data derivative. How do I keep that safe and access control? The access controls are correct around it. So there's a lot of different definitions of security in this space. Let me touch on the last one because that's
Actually, let me just interrupt for a second because she answered. It's preventing data exfiltration.
Data exfiltration. Okay, yeah. Okay, cool. That's something I do think about, and I think it's related to the last category. So I've talked to the government a lot about this because we've started engaging with them. But essentially, they have a lot of complex access controls, and obviously, data infiltration or other parties accessing different pieces of the data is a big issue, right? They have very complex access controls. Enterprises have this too. This is where actually LoRa's come in as something kind of magical. So what these extra brain cells are doing is they're essentially learning about facts in different documents, right? And let's say you have access to documents ABC. I have access to documents C, D, E, so a little bit of overlap on C, but otherwise different. These LoRa's can actually represent essentially a data derivative of extra brain cells related to each of those documents. And I only have access to CDE, and you only have access to ABC. Okay. And as we run the model, it can only select the relevant LoRa's related to what you have access to and what I have access to when it answers the same question. So it might answer it differently for you versus me as a result. So that's super important. Another really good piece of this is that because these extra brain cells are so lightweight, they're really small. They're not nearly as large as this big model. They can be stored as files. So if you wanted literal physical separation of your LoRa's, my LoRa's, which are just derivatives, compressed derivatives of your data, my data, you can do that. So you can literally have a physical data, just like how your data is governed, those adapters, those LoRa's can be governed in the same way. And so that's kind of how we approach access controls. I don't know if that's helpful.
No, that's very helpful. Let me stop this. So before I thank Sharon, I just want to say one thing because we started in someplace fun where you talked about sort of viewing some of this stuff as magic, and one of the things I loved about that is a little bit. I'm working on a book, and one of my chapters is actually called "The Magic of Software." And
Awesome. Yes, very magical.
there's a whole belief out there, which is sort of the purpose of software is actually to build something that to people from a different time would seem like it's magical that we could actually do that. And I think the field you're working on is just so important to humanity that I think it's really important. So first, I want to thank you because
Thanks for having me.
I certainly, I spent a lot of time studying the space. I'm not a computer science expert in LLMs for sure, but we read a lot of, and sort of you really have opened our eyes and taught us a lot about sort of where we are and what we might see coming. So thank you for sort of explaining sort of these complex subjects so well to a very large audience and lots of energy in terms of the questions we've seen. So thank you so much for sharing your expertise with us, and we really appreciate sort of your contributions because what we're trying to do at the center is really sort of have companies and individuals succeed in a world that is increasingly AI powered. And so for that, our deepest thanks to you. To the audience, thank you so much for joining us. We have been around for 12 years and you've been loyal supporters of the center for a long, long time. And we encourage you to continue attending our events. Please send us email if you have suggestions for themes you would like to see us cover. There's a lot of applause emojis, Sharon. I hope you're seeing them.
Yeah, they're so cute.
Aren't they? And always a pleasure to see you. And thank you to everybody. And then we will announce our next event relatively quickly. Thank you again, Sharon.
Awesome. Thank you, Vijay. Thanks, everyone, for listening.
And thanks, everyone. Bye-bye.